Welcome back to Math with Miss Reimer. On this cold winter's day, Stanley decided to go to school at the Reimers' Christmas Village since there was no school today. Hopefully they're staying nice and warm at the Essex School today. Welcome back to Math with Miss Reimer. Today we're looking at section 7b, monomials times polynomials. Something that will be helpful for us today is to recall the product rule. Product rule says if you have two bases that are the same, you can add their exponents. So for example, if I have 4a times 5a, I'm going to treat these two things separately. So look at your coefficients first. 4 times 5 will give me 20. And then we'll take a look at the a's. So a to the first times another a to the first means we'll do 1 plus 1 to give me 2. Basically, a lot of this is distributive property, which should already be pretty familiar to us. So in number 1, we're going to take the k on the outside, and we're going to multiply it by both pieces inside the parentheses. So k times k will give me k squared, and k times negative 9 gives me negative 9k. Remember that convention does state that you put the coefficient first, so the negative 9 and then the k. So in number 2, same thing, we're distributing. So we'll do 6p times p, which will give me 6p squared from the 1 plus 1 here. And then 6p times 8 will multiply 6 and 8 to give me 48. And then p comes along. In number 3, we take the 3c to both pieces. So 3c times negative 2c, 3 times negative 2 is negative 6. C times c is c squared. 3 times negative 5 is negative 15, and then the c comes along because it doesn't have anything to be combined with. In number 4, we'll take the x into all three pieces, so the same as our previous distributive property. This one just has 3 pieces. So x times x squared will give me x cubed because of the 1 plus 2. X times negative x will give me negative x squared, again 1 plus 1 in the exponents, and then x times 3 will just give me 3x. In number 5, we'll take the 5m squared and distribute it to each piece. So 5 times 3 will give me 15. M squared times m squared will give me m to the 4th from 2 plus 2. 5 times the negative, remember there's our imaginary negative 1 here, so that's just negative 5, and then m squared times m to the 1st, m to the 3rd, we add our exponents. And then lastly, 5 times negative 7 gives me negative 35, and then my m squared just comes along. You can see this is already in standard form. We go with 4, 3, 2, and our exponents are it. In number 6, when we have multiple variables, we still follow the same rules. Remember, you can only combine things that have the same variable. So our 3 will come to stay. X times x squared gives me x cubed, and y doesn't have anything to combine with, so it just comes into your answer. Again, we start with 3. X times x is x squared. Y times y is y squared. And then we keep our 3 again, our x comes, and then y times y squared gives me y cubed. In number 7, we are still distributing through, we just have more exponents and more variables here. So do it one piece at a time. So negative 4 times 9 will give me negative 36. Our c's, 3 plus 2, will give me 5, and our d's, 2 plus 2, will give me 4. And then negative 4 times negative 4 is positive 16. C, we've got a 3 and a 1, so that'll be c to the 4th. And then 2 and 5 will give me d to the 7th. In the next part, we're going to distribute and then simplify. So the same thing we've been doing, but adding the simplification part to it. So first, we need to distribute to get rid of any parentheses that we have. So we'll multiply in. Negative 2 times 3 is negative 6. X times x is x squared. Negative 2x times negative 4 is positive 8x. And then we have plus 7x here. Now we need to combine like terms. So we can only combine things that have exactly the same exponent and variable. So both of these terms can be combined together, and that will give me 15x. Once we've transferred over to simplifying, our exponents no longer change. They're only going to change when we're multiplying in. Once we're combining like terms, we're just combining things that are the same. So we get 15x here. The negative 6x squared doesn't have anything to be combined with, and so it comes down into our answer, and we can't go any farther than this. This is my final answer. In number 9, we've got 2 sets of distribution to do. So we'll take the 5 times negative 7 to give me negative 35, w squared, and then 15w. Over here, we'll get 2 times negative 2 is negative 4, w times w squared. We add the exponents and get w cubed. 2 times 19 will give me 38, and then w squared, and 2w plus 2 will give me 4w. And now we can go about combining our like terms. So my squares can go together. And then I also have two sets that are just w's. And my w cubed doesn't have a buddy, so it will just hang on with us here. So my w's come out to 19. My w squareds come out to 3w squared. And then the negative 4w cubed didn't get combined with anything, so it just stays. In number 10, I again have two sets of distribution to start with. So y times y is y squared plus 4y. We get negative y squared and positive 3y. And then the negative 9y wasn't a part of our distribution. So when we go to collect things, I get my y squareds, which you're going to notice is going to cancel out for both of them because you've got a positive and a negative. And then when I go to combine my y's, all the rest of them are y's. So remember, our exponents shouldn't be changing at all, so we just mess with the coefficients at the front. So 4 plus 3 minus 9 will give me negative 2y, and that's my final answer. In number 11, first we start by distributing, so we need to bring the front pieces in. So negative 2 times everything will give me negative 6m squared, negative 10m, negative 12, and then 3m times everything will give me positive 6m cubed, positive 9m squared, and 3m. And then we can, again, set about combining like terms. So we've got some squares we can put together here. Notice I'm always taking the sign in front there because that sign is tied to the term that follows it. Like this acts like a negative 10m. So we're going to get negative 7m out of my m's. We'll get positive 3m squared. And then my negative 12 is still at the back, and my 6m cubed is still at the front. And remember, we write them in exponent order, so that's why we've got our 3, our 2, this is a 1, and then our constant at the end. In number 12, again, we're going to start by distributing. So we'll take these all into each piece. When you distribute here, make sure that you take the negative x. That whole thing is coming in with us. So we get 8x to the 4th from adding our exponents. 4x cubed minus 5x squared. Oh, nope. That's better. We get negative 20x squared, and then we keep multiplying through, and we'll get negative x to the 4th minus 5x cubed plus 3x, and then plus 17 here. So now we can combine all of our like terms. So we've got a bunch here. So we've got our x to the 4th, so we can put together. Notice that minus comes with it. We get our x cubes that go together. Again, the minus comes with the 5. We get just our x's. Oh, and actually everything else is on its own. So we start with our x to the 4th, and we will end up with 7x to the 4th from 8 minus 1. Our x cubes will give us negative x cubed. X squared is next, so we'll go negative 20x squared, then plus 3x, and plus 17. Again, notice our exponents are in order, 4, 3, 2, that's the 1, and then our constant. All right, in 13, start by distributing, so we'll get rid of our parentheses first. So that will give me 12xy minus 8x squared y squared. Notice the x's didn't change, but the y's did. And then we just have everything that's already there. And in this piece, we've got these two terms that do have the exact same exponents and the exact same variables. So negative 8 plus 13 can be combined to give us 5x squared y squared. And then everything else just comes with us. So this is the highest power of 4, beats the power of 2 collectively of this term. So that's why that one goes first. And then there's our answer. All right, last two, and we'll be wrapped up. So this one has a double set of parentheses, which means I'm going to need to do distribution twice. So I'm going to do the innermost set of parentheses first, and then work my way out. So we get negative 15ab, positive 10b squared, and then the 2a squared is still out here. Turn this into a bracket, and then everything else. So now what's in our bracket is all being multiplied by 4b. So 4b gets pulled into all of these. So we'll end up with 8a squared b minus 60ab plus 40b cubed, and then the 29ab squared at the end here. When I look to find like terms, I can, oh, this should be a b squared right there. So these two can be combined because they're both ab squareds. So collectively, that'll give me 31ab squared. And then everything else just comes down. Notice that an a squared b is different than an ab squared. It has to be exactly the same exponents and exactly the same variables in order to combine them. And then last geometric application, we need to find the area of just the shaded region, so the inside part of this square. So in order to do that, we're going to find the area of the whole thing, the big thing that's shaded, and we're going to subtract out the area that's not shaded. So to find the area of the big rectangle first, we'll do length times width, which will be 6x times 8x minus 1. So that'll find me the area of the entire rectangle. And then I'm going to subtract out this little part that's not shaded. So the area of that part would be 2x times 5x plus 3. So when we distribute, we'll take that through. Make sure you take the minus with that 2x when you distribute. So we'll go 48x squared minus 6x and negative 10x squared minus 6x. And then we can start combining our like terms. So we've got two negative 6x's. They don't cancel each other out because they're not actually opposites, but they can be combined. And then our x squareds as well. So 48 minus 10x squared will give me 38x squared. And then that's our final answer. Remember the 5 things. You are lovable, valuable, changeable, forgivable, and never alone. I hope you're confident in the math. I hope you feel like you know what you're doing. More than anything else, I hope you know that I care. Thank you.